Why CNC machining is so precise? There are two main reasons for the high precision of CNC machines. 1. CNC machines employs a semi-closed loop control system. 2. CNC machine components of high precision. Let's start by discussing the semi-closed loop control system. A semi-closed loop system is a combination of a closed loop system and an open loop system. Imagine a scenario where a delivery person constantly updates you on their specific location. You can instantly instruct them to turn left or right, accelerate or stay still. This kind of control system, where instructions are issued, executed, results are returned, and adjustments are made, is a closed loop system. On the other hand, if a delivery person only informs you that they've started their journey to your house, without disclosing their route or whereabouts, you lack complete control over their actions. This type of control system, where instructions are issued, but no result feedback is received, is an open loop system. Clearly, closed loop systems are more precise and controllable. CNC machines use a closed loop system from the controller to the servo motor, and then an open loop system from the servo motor to the load. The specific control system consists of several components. Human-machine interface. Typically a screen with buttons and indicator lights. The human-machine interface converts the operator's intentions into language the controller can understand and sends it to the controller. Controller. Responsible for logically processing instructions from the human-machine interface and sending instructions such as speed, position, etc. to the driver. Driver. Converts instructions from the controller into specific voltage and current to drive the servo motor. Servo motor. Receives pulse current from the driver, rotates, and drives the rotation through the ball screw. Internal encoder. The servo motor contains an encoder, primarily to provide feedback signals such as speed and position to the driver and controller. Ball screw. Convert rotary motion into linear motion, driving the load to move at a specified speed to a designated position from the controller to the rotating servo motor. This forms a complete closed-loop system. From the motor's rotation to the load's movement is an open-loop system. In the entire control system, the most critical component is likely the grating encoder. Imagine a disc, part of it oct, and part of it unblocked. A laser beam is directed at this disc with a photosensitive element on the other side. If the laser passes through, photosensitive element outputs 1. The laser is blocked, it outputs 0. As the disc synchronously rotates with the servo motor, based on the output sequence of 010101, we can determine the servo motor's position, speed, and other parameters. Clearly, if a circular ring is divided into two halves, we can only determine if the motor has rotated 180 degrees. If divided into quarters, we know which 90-degree section it's in. Modern servo motor encoders can divide a circle into thousands or even millions of parts. This allows us to precisely know the servo motor's position, speed, and other parameters. These parameters are fed back to the controller, which calculates the difference between the actual and desired positions and speeds. Based on this difference, the controller sends instructions to the driver, which converts them into corresponding currents or voltages applied to the motor, driving the motor to accelerate or decelerate. This process is analogous to a delivery person constantly providing feedback on their location to you. If you find them too slow, you instruct them to speed up so they increase the throttle. If they are too fast, you ask them to slow down, and they brake. This continuous loop of feedback calculation, instruction issuance, implementation, and further feedback constitutes the closed-loop system in CNC. Of course, the involved mathematics and circuit control are highly complex. Thousands of engineers have invested substantial efforts to achieve millisecond or even microsecond level response times in modern servo motor systems, achieving control precision to 100,000ths or even millionths of a circle. This closed-loop system can ensure the accuracy of the motor's rotation. As for whether the load can reach the specified position after the motor's rotation, it depends on the ball screw connected to the motor and the subsequent mechanical structure. This is the open-loop system. The accuracy of this open-loop system primarily depends on mechanical clearances and rigidity. The loads on CNC milling machines and CNC lathes mainly come from the various forces generated by cutting tools. The rigidity requirements of the CNC mechanical structure are such that they experience minimal deformation under the influence of these forces. For this reason, the machine base is often made of cast iron, while Guide rails are made from various special hardened steel materials. The adoption of ball screws is aimed at minimizing plays during the system's motion. The play of a ball screw is determined by a series of larger diameter balls in contact with the screw. Therefore, even if some balls experience slight reduction in diameter due to wear, it won't impact the precision of the ball screw. Both the balls and the screw in the ball SCR/EW are made from specially hardened steel materials, preventing rapid changes in gaps due to wear. All components in this open-loop system are manufactured using grinding processes to achieve micrometer-level precision. In conclusion, the various components in the CNC open-loop system strive for optimal rigidity and minimal clearances through modern mechanical manufacturing processes. This ensures precision even in the absence of position feedback. Other factors that affect precision include temperature variations, tool wear, factory rigidity, external vibrations, and more. These variations are compensated for through programming or controlled by operators. This aspect is not discussed in detail here. So, are there fully closed-loop CNC control systems? Yes, indeed. These are implemented in CNC machines that utilize linear motors. We will explain this topic in detail in future videos.